So they want us to solve this system of equations by using matrices. So the first thing we need to do is understand how matrices help us solve this system of equations. So what I'm going to do is I'm going to create a matrix with the coefficients. This is called, of course, the coefficient matrix. I took 5, 2, 1, and 1. And then I'm going to create a variable matrix. And then I'm going to create a solution or an answer matrix over here. Now if you look at this right now, what you'll notice is if you multiply these together, let's think about what you do when you're trying to multiply this matrix times this matrix. What would I get? Well, I'd get row 1 times column 1 equals row 1, column 1 in my other matrix.
So it would
5x,
for the equation.
5x plus 2y equals 11. I would get that equation right there. Same thing with this one. Row 2 times column 1 gives me row 2, column 1. 1x plus 1y equals 4. So what I've done is I've converted my equation, I've converted my matrix into a matrix, my system of equations into a matrix equation, and now what I can do is I can apply algebra, because matrices work just like numbers do. If I had, for instance, a number times, if I had a number like 4 times x equals 7, how would I solve that equation?
Divide by 4.
I divide both sides by 4. Well, now, in matrices, I can't just divide by this. That's not legal. You're not allowed to divide by a matrix, but you can multiply by the inverse, which is what I could have done for this too. I could have thought of just multiplying by 1/4 instead of dividing by 4. So I'm going to do that. I'm going to multiply by the inverse of that matrix right there. So the inverse of this matrix is, if you remember, you take the determinant. 5 times 1 is 5 minus 2 is 3. It's 1/3. That's the determinant. And then you take these things and you manipulate them, you flip them around. I think you flip the 1 and the 5 there. These two you switch places. And these two you make negative. So there's my inverse matrix. That's my, if this is called A, this is going to be A inverse. And this is my B matrix right here. This is my X matrix. So if I have A times X equals B, that's my matrix equation. To get X by itself, I want to multiply by A inverse on the left. That's how I get rid of A. It's like kind of like dividing by A, multiplying on the left. So that's what I'm going to do. Here's my A inverse right here, and I'm going to multiply that times B, which is 11/4. Now notice I didn't distribute anything in. The reason I didn't distribute this 1/3 in is because then I'd have fractions to deal with this whole time. Instead, I'm going to deal with this right here. How do I multiply these together? So this equals, I'm going to leave the 1/3 out front. That equals what? 1 times 11 plus negative 8. So that equals 3. And what's this? Negative 11
Minus
plus 4. Negative 11 plus 4 is?
negative 7.
I'm sorry, not 4. Negative 11 plus 20
9.
is 9. And now I can distribute this 1/3 in, and I get what? 1 and 3.
1 and 3.
So what's the 1?
That.
That's my X, and what's the 3?
Y.
It's my Y. That's how I use matrices to solve the system. And of course, you should always plug in your solution to check your answer. So if I plug 3 and 9 in for X and Y respectively, 3 and 9, oh my goodness, that's not going to work. Did we do something wrong here? Or was that a negative 1/3?
Negative.
No, that's not a negative 1/3. I have a feeling one of these two things is supposed to be negative. 11 minus 8, negative 11 plus 20. No, either one of those are negative. 1 and 3 definitely works in this one. Oh my gosh. Of course
It's
1 and 3
1 and
work.
three.
It's not 3, it's 1 and 3, not 3 and 9. I was looking at the wrong thing. 1 and 3 does work in both of them. So
Yeah.
good thing we didn't disprove math.